In today's lecture, we will learn Mohr circle in a 3D plane. But before doing so, first of all, we shall do the quick revision what we have learned in the last class, so that we shall use those concepts in the today's discussion. In the last class, we have learned that sigma 1, sigma 2, and sigma 3 are the principal stresses, and they are along the normal to the plane characterized by direction cosine nx, ny, and nz. And if they are given like that, then we can find out the values of normal stress, shear stress, and resultant stress. And the results in that discussion was like this. So Tn square, the resultant stress, can be given by this formula: sigma 1 square nx square, sigma 2 square ny square, and sigma 3 nz square. Sigma 3 square nz square. However, this Tn square can be resolved along x, y, and z axes as Tnx, Tny, and Tnz. Then after we have seen that the normal stress can be given by sigma 1 nx square, sigma 2 ny square, and sigma 3 nz square. And the shear stress can be founded by this formula. And at the end of that class, I have also derived an expression for shear stress tau n. So now we shall start today's discussion, that is Mohr circle in a 3D plane. As you all know, Mohr circle is a graphical method to find out the normal stress, shear stress, and resultant stress. So for our today's discussion, we will consider again that there is a plane ABC which has a direction cosine n, and the plane is identified by its direction cosine nx, ny, and nz. And principal stresses along the plane is sigma 1, sigma 2, sigma 3. So that Tn is a resultant stress, and sigma and tau are the normal and shear stresses. So as we have seen in the last class or in the previous slide, sigma is equal to sigma 1 nx square plus sigma 2 ny square plus sigma 3 nz square. Let us consider this as equation 1. And the direction cosines are related like this: nx square plus ny square plus nz square equal to 1, so that one can write nz square like this, and this can be treated as equation 1 and equation 2. So our next task is to put this value of nz over here. So after putting the value, let's see how equation 1 changes. So after putting the value here, we can see that it is sigma 3 1 minus nx square plus ny square. Now next task is to multiply this sigma 3 by 1 and the term inside this bracket. So on expansion, the expression is like this: sigma 1 nx square, sigma 2 ny square, plus this sigma 3 minus sigma 3 into nx square minus sigma 3 into ny square. So taking common from sigma 1 nx square and sigma 3 nx square, nx as a common, we can write like this. Similarly, we can take common ny square from this and this, so that we can write this expression, and finally sigma 3 can be written here, so that sigma can be simplified as equation 3. So in this way we have derived equation 3. Now the resultant stress Tn square can be given by the formula we have just seen in the previous slide: sigma square plus tau square is equal to this much. Again, we can put the value of nz square here by this equation 2. So now we will put the value of nz square. After putting the value of nz square, we have substituted the value of nz over here, putting the value of nz square by equation 2. We have found sigma 1 nx square as it is, this is as it is, this is as it is. Sigma 3 is multiplied by 1, so that we can get a value this, and sigma 3 multiplied by this and this. Now on further simplification, what we can get, we have to take common nx square. We have to take common from this nx square, and we can take nx square common from here and from here, so that we can write it as nx square sigma 1 square minus sigma 3. Similarly, we can take ny square from here and from here, so that we can write it like this, and plus sigma 3 square. So taking sigma 3 square on the left hand side, we can write it like this, and this can be treated as equation 4. So now we have to solve equation 3 and equation 4, so that some variables can be omitted. So for that, we can multiply equation 4 by sigma 2 minus sigma 3. We have to multiply this equation by sigma 2 minus sigma 3, minus means we have to subtract with multiplying equation 3 by sigma 2 square minus sigma 3 square. This equation I am talking about. One is this equation and one is this equation. So after multiplication and subtracting, the values are like this. This tau square has been multiplied by this tau square is multiplied by sigma 2 minus sigma 3. Sigma square minus sigma 3 is again multiplied by sigma 2 minus sigma 3. Minus this minus is there. Minus we have to multiply this equation by sigma 2 square minus sigma 3 square. So we have done so. So this sigma is being multiplied by this sigma 2 minus sigma 2 square minus sigma 3 square, and it is written here. Now for the left hand side, again we shall start with multiplying sigma 2 minus sigma 3 in equation 4. So this equation is being multiplied by sigma 2 minus sigma 3, and this expression is also being multiplied by, no, this is not multiplied actually. This is being multiplied and this has been cancelled out. Ny square has been cancelled out. The term containing ny square has been cancelled out. So this nx square is being multiplied by sigma 2 square minus sigma 3 square, and it is written here. And this has been cancelled out. Sigma 3 after multiplication with sigma 2 minus sigma 3, it is written here. The term which we have cancelled, let me show you which terms we have cancelled. This term has been cancelled out. The ny square term, this term has been cancelled out, and this term ny square has been cancelled out, so that one variable is eliminated. So now in the next step, after simplification, what we can get, this term has been cancelled out. In the next step, so again I have written these steps so that you can recall that all the concepts all the expression has been copied from the last slide. On this slide, the last step has been written here. Now next is to cancel the common term sigma 2 minus sigma 3 from both sides. So the common terms, this sigma 2 minus sigma 3 has been cancelled out, this sigma 2 minus sigma 3 has been cancelled out, and sigma 2 minus sigma 3 has been cancelled out, and as a result we are left with sigma 2 plus sigma 3. So this one is sigma 2 plus sigma 3. Similarly, sigma 2 minus sigma 3 has been cancelled out. Again, we are left with here sigma 2 plus sigma 3 and sigma 2 plus sigma 3. So that we are left with tau square sigma 2 minus sigma 3 square minus sigma into sigma 2 plus sigma 3. Then after nx square sigma 1 square minus sigma 3 square, then after minus nx square sigma 1 minus sigma 3 into sigma 2 plus sigma 3, that is written here. That is written here. Then after minus sigma into sigma 2 plus sigma 3. So we shall now move forward for our next step. In next step, what we have done, this bracket has been opened and it has been written like this, and this sigma 3, the term, this sigma 3 term, this term is brought on this side so that we can write like this. And now nx square has been multiplied, nx x square is taken as a common, and all the terms has been multiplied inside the bracket. So that the first term was, it was sigma 1 minus sigma 3 square, it is written here, and this nx square has been taken as a common outside the bracket, and this sigma 1 multiplied with sigma 2, sorry, sigma 1 sigma 2, then after this sigma 1 is multiplied by sigma 3, this one is sigma 1, sigma 1 multiplied by sigma 3, then after sigma 3 into sigma 2, and then after sigma 3 square. So this has been done like this. Then after here some common terms has been taken. The common terms has been taken as this sigma square minus sigma 3 square has been converted by the formula of a square minus b square, and from here we have taken sigma 2 and sigma 2 plus sigma 3 as a common so that we can write like this. Then after here sigma 3 and sigma 3 square has been cancelled out, these two terms have been cancelled out, and in the next step after simplification the expression is, let me show you what is expression. So tau square is equal to, as we have taken common sigma minus sigma 3, this sigma minus sigma 3 has been taken common, this term has been taken common, sigma minus sigma 3, so that we are left with, so that we can write here sigma plus sigma 3 that has been written here, and sigma 2 minus sigma 3 after multiplication with this minus sign, it has been written here. And here we have taken common sigma 1 square, and from this expression we have taken sigma 1 as a common, and from these two expression again minus sigma 3 has been taken common, so that we can, in the next step we can write like this, sigma 1 minus sigma 3 sigma 1 minus sigma 2, and here after taking some common terms outside the bracket sigma 3 and sigma 3 has been cancelled out, so that this can be solved like this. In the next step we have to simplify it little bit more. So nx square can be written as like this, tau square plus sigma minus sigma 3 into sigma minus sigma 2, then after in denominator it is sigma 1 minus sigma 2 into sigma 1 minus sigma 3. You can see that nx means the first term, and in the numerator there is no any first term containing sigma 1, or anywhere there is no such term. Whereas in the denominator it is sigma 1 first term minus sigma 2 and first stress minus third stress. Similarly, we can do it for the other direction cosines ny and nz. So other direction cosines ny and nz are written in a similar fashion. Second term is there. Y is the second term. So in the numerator there is no any second term, and in denominator it is sigma 2 minus sigma 3 and sigma 2 minus sigma 1. And for nz being the third direction cosine, there is no any term containing the 3 subscript in numerator, whereas in denominator it is written as sigma 3 minus sigma 1 into sigma 3 minus sigma 2. So after deriving expressions for nx square, ny square and nz square, what our next step is to analyze these equations 5, 6 and 7. So now we will need to do some more analysis on equation 5, 6 and 7, and analysis can be done for 3 cases. 3 cases I will show you by one. Let's analyze nx square, ny square and nz square for the first case. Let's take the first case where sigma 1 is the largest principal stress, then after we have sigma 3 is the smallest principal stress, and sigma 2 is the line between sigma 1 and sigma 3. So by equation 5, so by this equation, since this nx square, the square term is always positive, so we can see that Since sigma 1 is the largest, so this is positive, this is positive. So in order to be this total expression to be positive, the numerator should also be positive since the denominator is positive. Let me show you once again how it is positive. Since sigma 1 is greatest of all, that's why sigma 1 minus sigma 2 is positive, and sigma 1 is again greatest of all, that's why sigma 1 minus sigma 3 is also positive. For nx square to be positive, the denominator should also be positive. So in the next step, we have to apply this condition at numerator so that it could always be positive. So as we have seen that numerator should always be positive, for that this term should be greater than equal to 0. That I have written here or copied here, tau square plus sigma minus sigma 2 into sigma minus sigma 3 greater than equal to 0. So on further simplification, this can be written as what we have done, only we have expanded the brackets and multiplied the term inside the bracket. So this is sigma square, sigma into sigma 3 and into sigma 2 into sigma, so that in a short it can be written like this. Then after this sigma 2 and sigma 3 has been multiplied, minus into minus it is plus and greater than equal to 0. Now on the further simplification, we can write it as sigma minus like this, and this term you have to analyze very carefully that how this term has come from this expression. This was a square and this can be written as 2ab. However, there was no 2, that's why it has been divided by 2. And in order to get this expression, this term has been subtracted. So in the next step, what we can see that it can be written like this: tau square sigma minus sigma 2 plus sigma 3 square, and this, when this term is brought inside this bracket, it is sigma 2 minus sigma 3 by 2 whole square, so that we can write like this. So this expression can be compared with standard equation of circle. This follows the circle equation when we compare this equation with standard equation of circle inequality. Why? We will only consider this equality symbol. Inequality symbol will be taken care in the next class, and I will explain it in detail that how to use or how to analyze this inequality symbol. So comparing with standard equation of circle, that is x minus a square y minus b square is equal to r square. So we have a as this, b would be equal to 0, and radius is equal to this. So the coordinates of circle are like this. X coordinate is y2 plus y, so x coordinate is sigma 2 plus sigma 3 by 2, and y coordinate is 0. Whereas the radius is equal to, radius square is equal to sigma 2 minus sigma 3 by 2. So using these concepts, we have to draw a Mohr circle for a plane in which sigma 2 and sigma 3 is lying, or for YZ plane. So for that we have drawn a circle. As you can see that this axis is used for normal stress and this axis is used for shear stress. So on this normal stress, since sigma this is sigma 2. Sigma 2 being the larger sigma, this is sigma 2, and this is sigma 3, the smaller quantity. So the radius, the center is at x coordinate is sigma 2 plus sigma 3, so and y coordinate is 0. That's why we have located the center at this point. and the radius is sigma 2 minus sigma 3 by 2. So a circle like this has been drawn. So in this way we have drawn the Mohr circle for sigma 2 and sigma 3 only for two stresses in YZ plane or in sigma tau plane. In the next class we have to analyze equation 6 and equation 7 to complete the Mohr circle for all three stresses. So for the today's lecture, I would suggest you to analyze equation 6 and 7 at your home so that you could have better understanding of Mohr circle for all the three cases when I will be discussing the analysis of equation 6 and equation 7. So this was all for today. Thank you. Thanks a lot.